All right, so it looks like question 5 they're giving us a conceptual problem. So we have the graph of function f as shown above. Which of the following statements is false? So we have a bunch of limits here, and we want to figure out which of these is false. So remember, guys, in order for a limit to exist, the limit as I approach some value from the right has to equal the limit as I approach some value from the left, at least in this case, right? And then what was the other thing? Sorry, for the same function here. Let me write that out. So this needs to equal this same thing right here. Okay, so hopefully that makes sense. Well, that's just kind of the definition of it. So we got to figure out which of these is false. So let's go ahead and look here. So the limit, and let's just do it one by one. So the limit as x approaches 2 for f of x, does it exist? So let's look at that. So as x approaches 2, so whenever I approach 2 here, I get this point right here. Okay, does that limit exist? Now, this is an interesting question, but the thing that you have to notice about it is that if I go from the left, I'm going to end up at this point, right? And if I go from the right, I'm going to end up at this point. So this entire function here, right, it would be a piecewise function, but when I would go through it and I would compute the limit, I would know that that is the limit whenever x approaches 2. So this is a true statement, so therefore it's incorrect in this case. Because remember, we want the false answer. Okay, so the limit as x approaches 3 for f of x exists. So limit as x approaches 3 for f of x. So again, that one did exist. Okay, so for 3, so I'm going to come over here to look at 3, and I'm going to go all the way up, and it is going to be this little sharp point. And again, if I come from the left, you will see that it is going to be at this point 5. If I come from the right, well, then it's just the same point, and it's the same function. So that one does exist, and therefore that one can't be the answer for this question. Let's look at D. So the limit as x approaches 5 for f of x. Let me clear some space here. All right, so whenever x approaches 5, we approach the y value of 6, and we can do that from both left and right sides. So yeah, that theoretically should be correct, right? And then, or I should say, that limit should exist, but we're looking for the false answer. Okay, the function is continuous at x equals 3, and again, when x equals 3, we're looking at this sharp point right here, and because there is a point there, right? There's not like a hole or anything. It is continuous. Now, it's not differentiable, right? Remember, the sharp turns, those are not differentiable, but they are continuous. So this is not what we're looking for. Okay, so that leaves us answer choice C, but let's go ahead and look at that for a second. So answer choice C is saying the limit as x approaches 4 for f of x exists. Now let's look at this, okay? Whenever I have my function here, so this is like one kind of function, right? And then this is going to be another function. Now the problem is that whenever I approach from the left, I have a hole right there. Okay? Now, whenever I approach from the right, I have a point. And the issue is that these are not the same function, right? So there is no way for me to know as x gets sufficiently close to 4 whether or not this limit exists, because I would have to use two different functions here, and unfortunately they are broken apart. So therefore the correct answer is going to be answer choice C. And again, it's correct because it is false, right? So this limit actually does not exist. So, okay, yeah, hopefully that makes sense. If you have any questions, feel free to comment below, and I'll see you guys in the next video.